Color, form, and texture are typical design parameters that you have with a lot of materials in exterior applications. But when you add an element of translucency, it can take your exterior design to a whole new level. Traditionally, when you're considering exterior applications and the tools that you have to be able to create those, you're looking at materials such as wood, stone, metal, and in a lot of cases glass. However, an untapped technology is this whole technology of resins that can be used in exterior applications. Resins can incorporate things like shape, color, translucency, and high performance that really isn't achievable with some of the traditional materials such as metal, glass, and wood, and stone. In this program, we hope to open your mind to some of the design possibilities that are available with resins for exterior applications. And more importantly, to help you feel comfortable, confident, and even inspired to design with resins. Even though resins really started to emerge around the early 1900s, the first real commercial building applications for resin didn't really occur until about the 1940s. In the 1940s, traditional materials came under high demand in order to support the war efforts. So, new materials were needed in order to offset the demands on the traditional materials. One of the first materials considered for replacement was that of glass. And it was done so with acrylic. Acrylic has the same look as glass, very high clarity, as you can see. However, it also had some additional benefits that were kind of not really known at the time. One of the benefits was that it's about half the weight of glass. Another interesting benefit is about twice as tough as tempered glass at the same thicknesses. So it was kind of a unique opportunity to start to look at traditional materials and the advent of resins into building applications. With the success of acrylic in terms of glass replacement, new processes and new performance characteristics were added to different resins to offer alternatives to that exact same application. Materials such as polycarbonates and polyester started to emerge to offer performance and cost benefits that weren't necessarily being met by both glass and acrylic. The acceptance of resins as alternative materials to glass was being adopted almost faster than the technology could keep up with. And with that, as resins started to be utilized more and more, we started to identify potential problems with particular types of resins. One issue was the abrasion resistance of the materials. Another was the UV resistance of the materials. And with all emerging technologies, you're going to find opportunities to improve the existing base of technology. That's how technology advances over the years. There's many things that you can think about in your own personal life today that you wouldn't do tomorrow. For example, how many times have you ridden your bike without a helmet? How many times did you get into a car without a seatbelt? Or thinking about things like exteriors, where the sun, you know you're supposed to wear sunscreen when you go to the beach. The advancements in technology are always set out to address existing problems with products, processes, or even systems. So, the quick adoption of resins as an alternative building materials really fostered additional research and development for resins to be used as building materials in exterior applications. The widespread adoptions of resins can be demonstrated in a number of different industries. One of the best industries to use as an example was the automotive industry. As weight was trying to be trimmed from cars to improve efficiencies and safety, one of the earliest substitutions was that of the glass headlamp. Traditionally, automotive headlamps were made out of a glass lens and aluminum housing. Today, you will see those being produced with engineered thermoplastics, such as polycarbonate. The introduction of polycarbonate introduced unique benefits that were never achievable with glass. For example, with polycarbonate, it was much more easy to achieve new designed shapes to help with aesthetics and with aerodynamics. Plus, you also had additional benefits of extreme impact resistance and very low weight. It's through the example of resin being used in a demanding exterior type application in automotive that you can see resin pioneering new applications in exteriors such as building products of today. As building sciences and resin technologies started to converge, several resins started to present themselves as ideal materials to be utilized for exterior applications. I want to take a little bit of time to talk to you about some of the differences of these resins because they each have their unique benefits. These are acrylic resins, polycarbonate resins, polyester resins, and polyethylene-based resins. The first consideration for any exterior application has to be polycarbonate. Polycarbonate is an extreme material. It's able to withstand some of the most horrific environments, whether it be very, very high temperature environments or very, very cold temperature environments. It can withstand things such as impact from hail, hurricanes, and it's used in a myriad of applications. It really is an amazing material to be able to use as a building product. Another excellent resin option for exteriors is acrylic. Like we said earlier, it was one of the first materials to be utilized as an alternative building material. Acrylic has some really nice characteristics in terms of its ability to transmit light and offer clarity. Still very lightweight. It offers additional benefits of improved impact performance over glass, but also offers unique fabrication capabilities that just really aren't very possible with other traditional materials. Another category of materials that's really unique for exterior applications is that of the polyester family. Polyesters for exterior applications offer a very unique benefit, and that's the ability to bring in shape. It really has the ability to transform an exterior environment. In addition to that, it offers the unique benefits of added toughness and good chemical resistance to be able to be utilized as exterior application. A last category of materials is that of the polyethylene family. Polyethylenes in exterior applications have some unique benefits. They're very chemical resistant materials and are very, very lightweight and easy to work with. Plus they can bring in the dimension of color, and they have a very important benefit, and that's their ability to be recycled very easily. With those 4 unique categories of resin alone, you're now offered an amazing toolbox of materials to be able to design exterior applications. In exterior applications, you deal with a wide variety of different fitness for use criteria. We'll demonstrate to you some of the differences of how the resins perform in terms of deflection, impact resistance, long-term outdoor stability, and things like shading and lighting and color options into the applications. So from an engineering perspective, it's really important to quantify and assess the performance of materials in order to be able to couple the advanced material technology with today's building science. Interiors tend to be much more forgiving. Exteriors, you really need to know your stuff. One of the very common questions people have about use of resins for exteriors is that of its weatherability. To understand how we evaluate resins in terms of their weathering performance, it's really important to understand a little bit of the difference amongst the resins themselves, because they are made of different chemical compositions. And when we talk about materials being different, we're not just talking necessarily about resins, but all materials actually have some effect by the weather. Acrylic was a very, very successful used material in replacement of glass because it actually had no ill effects when it was exposed to UV light. And acrylic has a very unique chemical structure. It's actually an aliphatic compound. In organic chemistry, an aliphatic compound is basically something that is made with straight chain carbon-carbon bonding. That carbon-carbon bonding is actually impervious to UV degradation. When engineering thermoplastics started to emerge to introduce additional performance benefits over acrylic, a new type of chemistry was being introduced into exterior applications. This chemistry was an aromatic chemistry. In an aromatic compound, you have 6 carbon elements that are oriented in a ring-like structure. But the bottom line is, it's this ring-like structure that is susceptible to UV degradation. That very simple discussion leads to the question of, okay, really, how do you stabilize these materials? Well, think of it this way. It's a simple difference of knowing when and when not to use sunscreen and how much to use. With the understanding of the mechanism of degradation, we're able to overcome and actually shield the materials and protect them for long-term outdoor use. So materials that are aliphatic in nature really don't need stabilization at all. Materials, though, that are aromatic in nature, materials like polycarbonates and polyesters, do need a level of stabilization. The point of this whole discussion is really not to make you a PhD in organic chemistry. However, what we do want you to understand is that advances in materials engineering has really come a long way in order to make these materials fit for exterior use. So how do we test UV stability? It's a very important thing to understand. Well, the first thing is time. The real test to prove something that lasts for 10 years is to see how it lasts for 10 years. However, realistically, nobody has time to do that, and therefore, test methods need to be employed to really accelerate the weathering process on a material. Accelerated weathering testing is a very well quantified science. What we're really attempting to do is emulate the radiation of the sun, but just increase the intensity to speed up the process. The method most applicable to plastic materials is ASTM G155 standard. In this standard, special bulbs are used to emulate the wavelength of the radiation emitted from the sun in the UV range. If a resin is inadequately protected, there's 2 things that can happen. One is a noticeable color shift. The other is a reduction in its physical properties, most likely exhibited in its loss of impact strength. Even though accelerated methods are employed, it's really important to see how it correlates to actual UV exposure. And in testing methods in the United States specifically, it's really good to have 2 different test zones. Globally, the 2 most extreme environments would be the tropics or the deserts. In North America, we have both. It's very common to look at test results that come from South Florida or from the Arizona desert. These conditions are simulating 45 degrees, south-facing, fully exposed conditions. However, not every application is in Florida and Arizona. Just the very location gives you some mitigating factors. In the summer, Boston and Florida have a very similar amount of average daily solar radiation. However, when you consider December, that solar radiation in Boston drops by as much as 50%. When you take that on an annual basis, you probably have maybe 70% of the total available daily average solar radiation in Boston that you do in Florida. So you'd expect any material that can survive Florida-type exposure will undoubtedly be even better in Boston, Massachusetts. Other mitigating factors that one might consider might be things that are locational in nature. Those things would be like, for example, an application that's installed near a large building. Maybe the application is north-facing, not south-facing. Or perhaps maybe there's large landscaping or other factors that create some shading effects, thereby protecting the material from solar radiation. So it's generally very well known that UV light can really pack a punch on organic materials. Hence, massive advancements have been made in order to understand the mechanisms of degradation and also the ability to incorporate new stabilization techniques to protect the materials to be able to be utilized for long-term exterior applications. In consideration for exterior applications with any material, a lot of times you're going to have to look at the forces that are imparted upon that material in its application. All these forces create important considerations for material selection, perhaps material thickness, or even the assembly that you use with the materials in their applications. So in consideration for the different loading factors, whether it be from snow, from wind, or even concentrated loads from such forces as when people sit, walk, or lean on a surface, you usually look at the flexural properties of the materials. Because the flexural properties of the materials are well known and quantified, we're able to conduct finite element analysis, which allows us to understand the deflection and the actual forces that are going to be imparted on a given panel. What's really important to know is the spans, the thickness, the actual geometry, to be able to conduct the right analysis of what will happen when a material is subjected to a given force. Oftentimes, there's a lot of extra capabilities that can be imparted with the resins. With the resins, you're easily able to incorporate shape, thereby imparting additional structure. The shape can be something as simple as a mild radius curve, or the shape can be complex, creating a robust structural panel, yet still giving you amazing aesthetic effects. Resins, being thermoplastic materials, have some unique considerations when it comes to looking at effects of temperature on the materials themselves. One of the effects of temperature is the degree of expansion and contraction that a resin material will see. Because expansion and contraction is a real thing with resins, there has to be considerations in the design of any exterior application that utilizes resins. Oftentimes, over an 8-foot length, you're having to make a consideration for as much as 6 millimeters or 1/4 of an inch of movement. So where you see resins being utilized oftentimes is in applications that really bring in aesthetic or even some performance elements, but are not necessarily being looked at in terms of their building insulation characteristics. Applications such as fins and balustrades, exterior canopies, even decorative elemental portals. Those are applications where you'll oftentimes see translucent materials actually being well supported by resins in their applications. One of the very important characteristics of resins is the material's ability to withstand tremendous amounts of different types of impact forces. Forces that come from, say, hurricane and tornadoes, hailstorms, vandalism, or even in applications that require a high degree of safety. You want unmatched impact performance. In order for materials to comply with South Florida Building Code, which is the preeminent standard in terms of hurricane impact performance, an 8-foot long 2x4 has to be launched at a product at a speed of about 50 feet per second. What we will demonstrate in this experiment is that all the materials actually do fairly well in terms of prohibiting the flying debris from penetrating the material. However, what you will notice is there's a very different effect among given materials. In one experiment, we showed polycarbonate at a 1/2 inch thickness. It's supported in a fully framed condition. Polycarbonate, following subsequent impacts, finishes the test virtually unscathed. In another condition, we take the same polycarbonate panel construct, yet subject it to the same impact using point supports. In another case, we'll demonstrate the effect of acrylic. Acrylic is a tougher material than glass, having roughly about twice the toughness of tempered glass. However, you will see that the toughness of acrylic still is not quite that robust in a 1/2 inch thickness. As you can see, even though the acrylic cracked, there was still no infiltration of the flying debris. And in another example, if we increase the thickness 2-fold, you can get amazing results with acrylic. Laminated glass also is able to withstand the penetration of the flying debris. But what's very important to understand is in an application that the glass, after impacted, is now completely destroyed and must be replaced. So as you can see, all the materials were able to provide an initial level of security. However, to protect your long-term investment, it's important to understand that some of the materials are capable of giving you a much higher level of performance. Anybody that's gone to a public swimming pool and has walked out barefoot and has stepped on hot asphalt knows that the color black is the ultimate heat-absorbing color. In today's building design, shading and thermal efficiency is actually paramount. With exteriors, especially, this is a consideration. Rather than letting the heat into a building, wouldn't it be nice if you could screen that heat before it gets into the building? Resins can incorporate that into your design toolkit. Take, for example, light transmission. Looking at a polycarbonate material that is 5 different colors, ranging between very, very light and quite dark, there's quite a difference in the light transmission that passes through the material. For example, in this case, clear and white, you can see that there's a dramatic performance difference in the amount of solar energy that is reflected just by the choice of color. These different levels of light transmission can translate to different shading performance criteria for your application. A very common question about resins in general is, how do you maintain these resins in comparison to glass? Well, one of the nice things about resins is they actually have a very good chemical resistance. What that chemical resistance translates to is the actual bite that a reagent might have into the panel itself, or even other reagents such as fertilizer, de-icing fluids, or anything of that nature. A big question often asked about resins is, how do you prevent graffiti? Oftentimes, a lot of people don't understand that resins, if you use the right cleaning solutions, it's very easy to remove the graffiti. While we're on the subject of durability in terms of use and abuse type applications, finishes on the resins actually go a very, very long way. In the case of polyesters, polycarbonates, and even high-density polyethylene, more subtle abrasion-resistant finish that's actually achieved by just raising the surface a little bit helps hide incidental scratches and marring. Glass, in comparison, often doesn't have the ability to hide incidental contact scratches, and it definitely is not repairable. In fact, when you scratch glass, you're actually compromising the physical integrity of the material. Because the composition of every material is different, so are the physical properties of each material. And therefore, it's important to understand the importance of each property and its effect on a material's application. One of the unique attributes of resins, whether it be exterior or interior applications for that matter, is their ability to be recycled. Generally, acrylic resins, polycarbonate resins, polyester resins, polyethylene, they're all utilized in a myriad of different applications. Everything from durable goods, such as vacuum cleaners and washing machines, to commercial packaging and medical applications. The wide range of the material usage in a multitude of industries does create a nice and ample recycle stream to be incorporated into the resin-based materials. In addition to the recycling factors that can be incorporated with resins, other important considerations from an environmental standpoint can also be included when considering resins for exterior use. One of the factors is that you can use the resins to practice solar management. A nice aspect of using resins is you incorporate a level of color before the heat actually gets into the building, thereby mitigating the amount of heat gain inside the building. Another important factor is just the long-term use and durability of the materials, something that won't break, something that won't have to be replaced, and something that can actually add an element of safety. Through the course of this program, we've talked a lot about emerging exterior technologies that resins introduce. Probably on the forefront of these emerging technologies is the incorporation of photovoltaic into panel design and/or glass. Photovoltaic technology has been around for quite some time. Generally, it's in silicon or polysilicon wafer chips, and they usually go on the top of a building. New technologies are coming out today with flexible films. Films that can be incorporated into having things like shape and form. A unique application with resins can be achieved through photovoltaic and incorporating a new element called design integrated photovoltaics. Design integrated photovoltaics is a simple description that really is incorporating the use of photovoltaic collection media in a design application that actually has a functionality. That functionality could be something like a canopy, could be a roof, could even be something such as a guardrail, or even something simple like a street furniture or a bench. However, these technologies have a couple of trade-offs. The trade-offs generally are that of efficiencies, and sometimes even on commercial availability and scalability. Because of the emerging nature of the technology, these considerations are always looked at on a case-by-case basis. In these case analyses, it's important to understand what your application target is in terms of performance and fitness for use, but also what your power requirements and your goals will be in terms of energy creation and energy management. There are a lot of ways that design integrated photovoltaics may be something you would like to explore.
The challenge was to infuse the Abraham Javits Theater with impactful design and functional shade for outdoor events. The design solution included a variety of bold colors in circular formation. The material specified was recycled content polycarbonate in a number of custom colors. The challenge was to create an eye-catching entrance to the Sangria restaurant that welcomed visitors, while also creating a sense of wonder. This required a material with custom capabilities, one that was lightweight, and one that had the same consistency in both exterior and interior grades. The team specified the integral custom graphics in both recycled content polycarbonate for the exterior and recycled content copolyester for the interior section. The result is the canopy glows consistently from within at night to protect visitors from the elements and provide a colorful, inviting beacon. The challenge was to design a facade that would act as both a rain screen and would reinforce the media station as a beacon of learning. The solution was to use resistant and translucent resin panels as the rain screen, and thereby creating a media screen to project color and video with 7,000 LED nodes. The team chose translucent polycarbonate in a milk white for its extreme durability and its translucency. During the day, the striking translucent box brightens the street front and draws pedestrians to the area. The challenge was to design a winning concept that would revitalize and use sustainable practices in the San Francisco public transits. The winning transit shelters consisted of an industrial structure with bold, iconic roof design element. The concept for the undulating top of the shelter was inspired by seismic waves and the rolling hills of San Francisco.
We actually did go into polycarbonate fairly quickly with the idea. We thought about glass and possibly metal, but it was really important to us to have a product that could withstand, pretty serious abuse, and as well as, withstand the elements out there.
People like the photovoltaic idea, which we proposed in there. They don't use very much energy. We've put in all LED lighting, so the lighting loads are very low.
From the get-go, we were really looking at materials that had a high recycled content. We definitely wanted the roof to have a good level of recycled content, so that was quite important to us and to our client and to the city of San Francisco.
These days, I think there's a lot more focus on street furniture and the quality of the street experience, and changing those, honestly, I think will make a really big difference on the way San Francisco feels from a street level.